Okay. Third period we did 1, 4, 7. Fourth period 2, 5, 8. So this period is the easiest to keep up with because it's the multiples of 3's. So we'll do 3, 6, 9. We'll still land with 5 or 10 minutes left, so if we pass something on the way that you want to see, we'll have time to go back and revisit if there's one you still have questions on. Number 3. The sequence 5, -1, -7, -13 has an explicit formula given by, well, it's multiple choice, so I could just plug in n equals 1 and 2 and 3 and 4 and see which one matches. But I'm going to build it on my own here. The common difference is -6, going down by 6 each time. So I know it's got to have a -6n in it. Positive 6n, that would mean d is equal to 6, that's out. D is equal to 5, that's out. And so it's not just multiples of 6 though, so that's not it. See, if I add 11, if I plug in 1, I would get 5. If I plug in 2, I would get, or excuse me, we get -5. No, I would get 5. That's right. If I plug in 2, I would get -1. If I plug in 3, I'd get -7. So yeah, that one's it. That's the nice thing about it being mostly multiple choice is you don't have to come up with the formula on your own. You can just see which one works. Number 6, the fifth term of the sequence given by, well, the fifth term, that means n equals 5. So let's just plug in 5. 8 times 1/2 to the 5 minus 1. That'd be 8 times 1/2 to the 4th. 2 to the 4th is 16. 8/16 is 1/2. Probably hoping there's a bunch that are that level of difficulty. Number 9. Write that sequence using sigma notation, but this one's not multiple choice, so I am going to have to do this one kind of on my own here. Let's see. Let's first figure out what's going on here. We're multiplying by -2, so r is -2. So I'm going to say that the nth term is the first term times r to the n minus 1. So you could leave that as your answer. 1, 2, 3, 4, 5, 6, 7. So that would be from 1 to 7 of -2 times -2 to the n minus 1. That would be okay. If you were thinking about this, you might say, wait a minute, this is just -2 to the n, like -2 to the first, -2 squared. And so you might write it like this, but those are equal to each other. And so either answer would be equally okay. In fact, there's an infinite number of ways to write that. You could start at 0 and go to 6. You could be really weird and start at 3 and go to 9, and then you'd have to really mess with the equations. Like you would want to pick one of these probably, but there are an infinite number of other ways to write that sigma notation. Number 12. All right, the whole test is without a calculator, and so to be able to test some of the big things or big numbers, we can give answers that look like this, where you don't actually figure out what 3 to the 10th is. We'll just leave it unsimplified. All right, sum of a geometric series, 10 terms, so that's a1, 1 minus r to the n over 1 minus r. That's my geometric sum, but a finite sum, not an infinite sum. So I need the first term, I need the r, and I need the n. hopefully they give me all of those things. First 10 terms, so n is 10, how many terms there are. Common ratio of -3. And first term of 2. So yeah, that's as nice as they can make that problem. They just hand you all the pieces you need. So 2, 1 minus -3 to the 10th, all over 1 minus -3. Okay, well obviously that doesn't look exactly like any of those, so I need to do some simplifying here. I notice that none of these have -3 to the 10th, so 1 minus, but if I 10th the negative, that's going to be positive, so I'm just going to write that as 1 minus 3 to the 10th, and now it matches my answer choices. And 2 over 4, yeah, 2 over 4 leaves a 2 in the bottom, so 1 minus 3 to the 10th over 2. So, had to know the formula, had to know where the things went, had to do a little bit of simplifying, but you did not have to mess with 3 to the 10th, because who knows what that is. By the way, even though I'm recording, you're still free to stop, ask questions if something pops up. Number 15. Find the sum of ... So this is an infinite sum. And the only formula we have for infinite sum is a1 over 1 minus r. But to use that, r has to be less than 1. So let's see. To get from 1/3 to 2/9, we're multiplying the top by 2 and the bottom by 3. That's easy enough each time. So there's my r. R is 2/3, which is less than 1. So like we're eligible to use the formula. So first term is -1/3. 1 minus 2/3. So that would be -1/3 over 1/3. Oh, I can do that without even doing keep it, change it, flip it. It's -1. Infinite sum formula. Make sure you check the r, because I promise you there's going to be questions, like maybe number 16, where r is not less than 1, and so you could use the formula, but you won't get an answer that makes sense. So we're not supposed to do 16 in this video, but r is 5, so it's not going to have a sum. I don't have to do anything. Like, that's just not going to work. Number 18. Order the following from least to greatest. From least to greatest. They're all infinite. I'm trying to see if there's like a shortcut to tell which one's least and which one's greatest without actually doing the problem. But because they start at different things, 1, 4, and 0, and there's different r's, like I think I'm just going to have to calculate all 3 sums and then just put them in order. The r is good for all of those. 2/7, 1/2, 1/4. All those are less than 1, so we're good there. First term will be 2/7, and r is 2/7. So 2/7 over 1 minus 2/7. 2/7 over 5/7. That would be 2/5. Keep it, change it, flip it if you need to. Multiply top and bottom by 7 if you want to. Alright, number 2. If I want the first term, this is what is a little bit, I don't know, misleading about that formula. A1 does not mean plug in 1. It means the first term. So what am I going to plug in to get the first term on this series? 4, because that's the starting number. So it feels a little weird to say that A1 equals and then plug in 4, but A1 doesn't mean plug in 1, it means first term. So 32 times 1/2 to the 4th. Let's see, so that'd be 32 over 2 to the 4th is 16. So the first term is 2. And the R is 1/2. So 2 divided by 1/2 is 4. And then lastly, again, it doesn't start with 1, but that's fine. Just plug in the low number, the starting number, because that's what we mean when we say the first term. 1/2 to the 0 is 1. R is 1/4. So S equals 1 over 1 minus 1/4. 1 minus 1/4 is 3/4. 1 over 3/4 is 4/3. So least to greatest with fractions. It could be tricky, but given the fractions we have, this isn't bad, because we got one that's less than 1, one that's a little more than 1, and one that's definitely more than 1. So 2/5 is the lowest. So I need to start with 1. And then 4/3 comes next. So answer E. 1, 3, 2. Don't you hate problems like that? Like they forced you to do 3 problems in order to answer 1 question. Not very nice. 21. I think I might skip 21 because it's the same question, right? Like it's different numbers, but it's the same thing. Like we're going to infinity, so it's the same equation. All of the R's are good. Again, we're emphasizing that we're starting at different places. So I think 21 tests exactly the same thing as 18, so I'm going to skip 21. We can come back to it later if you want to see that. 24. Which of the following is equivalent to add up 4 plus 8 plus 12 plus 16? Okay. Well, what I might want to check first is the sort of the inside, which one matches the term. And I think 4n would match the term. Right, if n is 1, 2, 3, 4. So I like this. 4n minus 4. I got to be careful. That might match the term if we didn't start at 1. But if I plug in 1, if n equals 1, a1 equals 0, so that guy's out. 4n plus 4 doesn't seem right, but if I start at 0, then my first term would be 4. And if I plug in 1, my next term would be 8. So, so A and C both work so far. If I plug in 1 for D, I get 8 and 12, so that one's out. Oh, so I need to be careful here. If I'm going from 4 to 100, and I'm adding 4 each time, it's like how many terms will I have? How many terms should I have? That should be 25 terms. So answer A is really tricky because it looks right until you think about that last term. If I plug in 24, my last term would be 96, so he's out. This guy, if I plug in 96, I would get 100. So starts at 4, ends at 100, so answer choice C. really tricky that A is the first answer choice, because that's the one that looks right until you get to the very end. (27) Which is true about that series? Well, we're adding up, and we're adding up infinitely, but what's happening with my terms? My terms are getting bigger, so this is not going to add to anything. So I don't need a formula. This diverges. The sum is headed toward infinity.
Did you say it diverges if it's getting bigger but it's not going to infinity, like if it stops?
We only use the term diverges if it's an infinite. If it's infinite. Because if it stops, maybe this is what you're asking, maybe if it stops anywhere, then you can add that up. It doesn't go to infinity. This is one where, let's see, I think there is a common r, 3/2, which means you could use the formula. I mean, you would be wrong, but you could plug things into this formula, and my guess is you would land at one of those numbers, but it's not right, because you can't use that formula when r is greater than 1. So I should be careful. If r is greater than 1, then we say the series diverges. But that's sort of the math technical stuff. Just look at you can't add up an infinite number of numbers where they're getting bigger. That's just not going to work. 30, more infinite geometric series. Has a sum of 11. First term is 7, and find r. So this is like a straightforward algebra question here. Just use the formula and plug in the pieces. Sum's 11, first term 7. So 11 times 1 minus r equals 7. You could distribute the 11 if you wanted to. I'm going to leave it alone and just divide by it. Minus r is 7/11. So r is 1 minus 7/11. So that would be 4/11. Just a little bit of algebra on that one. We just barely avoided number 32, where we had to, although those aren't infinite, so that would be a separate question. Number 33. Which of the following is true? Every infinite geometric series with common ratio in r and first term a has a sum of a over 1 minus r. Is that true or not true? Ashlyn, you're shaking your head no, and you are correct. Why is it not true?
Because it was a specified with the absolute value of 5 plus 1.
Right. This formula works only if r, absolute value of r, is less than 1. So it's like, it's almost true, but no, it's not, because of the r. To determine the sum of a finite geometric series, okay, that formula is a1, 1 minus r to the n over 1 minus r. You must know the last term of the series. No, I don't need to know the last term of the series. All I need is the first term, the r, and the n, so that's not true either. Every infinite arithmetic series diverges. Arithmetic, so like we're adding 2 or subtracting 7, and if we do that forever, then yeah, we're going to diverge. Like, it might diverge to positive infinity, it might diverge to negative infinity, but you're diverging either way. You have to add smaller numbers in order for it to converge. So C looks to be true. Let me read D just to make sure. No series can be both an arithmetic series and a geometric series. Oh, that's a tricky one. So We're thinking that's false because we're pretty sure C is true, which means there should be a series that is both arithmetic and geometric. Can you come up with a series that is both arithmetic and geometric? I don't think we talked about this earlier. Once you see it, you'll understand it, but until you see it, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. What's the common difference? 0. So that means it's arithmetic. What's the common ratio? 1. That means it's geometric. So it is both arithmetic and geometric. And so that means the only arithmetic and geometric sequences are ones that it's all just the same number. So it seems like it might be a weird sequence that is both. And I guess it is weird, but it's not weird crazy. It's weird boring. So yes, every arithmetic infinite series diverges. 36. Okay, this would be really hard if you didn't know what factorial meant without a calculator. But we know that means just count your way down. I'm going to stop at 8. That way I can just cancel out 8 on down. Alright, so now it's just like pairing up things to cancel. And 4 times 3 is 12, so that makes an easy thing to cancel. The 2 would reduce with the 10, making 5. And so, again, the only problem with these is be neat and be careful so that you can see what's left. Let's see, 11 times 5 times 9. I'm going to pair those up differently. I'm going to say 11 times 9 is 99. And 99 times 5, given my options, is 495. Yeah, 5 short of 500. 1 5 short of 500. All right, finally we get to some binomial theorem and or Pascal's triangle. Polynomial function is given by x plus 2 to the 5th. Which of the following expressions is true? P of x equals x to the 5th plus 32. No, I didn't. We need to come up with some punishment for someone who picks some sort of, public humiliation that would also not get me fired. So it's like the fine line there of how to put someone on the spot without completely humiliating them. Definitely not that one. After that, I don't know. I'm going to have to use Pascal's triangle. So if I'm going to build it, I can start with the 3 1s. 1, 2, 1, and then I'm just adding the 2 numbers above to get the number below. And obviously I need to go to 5. So 1, 5, 10, 10, 5, 1. Now, B looks tempting because it's 1, 5, 10, 10, 5, 32. But I don't think that's right. Alright, let's just space it out here. 1, 5, 10, 10, 5, 1. There's my coefficients. Then I like to go one variable at a time. So I know the first term will have x to the 5th, and the next one will have x to the 4th, and down we go until we run out of x's. Right, that didn't help too much because I'm still looking at all of those. The next term is 2, so I'll start counting up with my 2's. So no 2's on the first term, 1 2, 2 2's, 3 2's, 4 2's, and 5 2's. So let's see, they all have x to the 5th. 5 times 2 is 10. 4 4 times 10 is 40. I think I've already got my answer picked out here. But I'm just going to work the rest of the problem. 2 cubed is 8. 8 times 10 is 80. 2 to the 4th is 16. Times 5 is also 80. And 2 to the 5th is 32. So yeah, it's answer choice C. And then lastly, at least video anyway, determine the coefficient of x to the 15th in the expansion of 2 minus x cubed all to the 7th. Okay, well, somewhere, or actually not somewhere, every single term is going to have 2 to a power and negative x cubed to a power. And I know those powers will add to 7. I'm thinking about the binomial coefficient out front. Oops, 7 factorial. Okay, so if I want x to the 15th to show up, then what power needs to be on x cubed? Power to a power, we multiply. So put 5 out there. I get this x to the 15th. What does that mean needs to be on the 2 now? What exponent needs to be on the 2? Why 2? So I got to add the 7, so this one's got to be 2. And then I'll use those two things as the denominator factorials. Okay, so there's the term. Now I need to clean it all up to figure out what the coefficient is. So let's see, 7 times 6 times 5 factorial over 2 times 5 factorial. So 42 divided by 2 is 21. 2 squared is 4. And be careful, it might look like it's 84. If I fifth a negative, that's going to get me negative x to the 15th, so it's negative 84. I don't know where the 76 comes from. All right, again, this is the thing that looks really complicated, but this number, the overall power is always in the top, and the two smaller powers add to the top power and are in the bottom. That way you can jump to any term you like. If you wanted to blow the whole thing up, then you'd probably go to Pascal's triangle, go down to the 7th row, and pick off all the coefficients that way.